All right. The second talk is called A Beginner's Guide to Build Servers. And I hope that after this talk, you are all able to set up such a build server for one of your projects. We can skip this slide actually, because we already saw that in the previous talk. And I can directly start with our overview. First, I'm gonna outline why building your game manually sucks. We heard a bit of this in the previous talk, but I'll go into more detail right now. Then we will look at build servers and how they help us getting rid of these manual processes. We will be looking at some of the available options. I included some slides for installing Jenkins, which is the option that we chose, but I guess we might skip this because of time reasons. You can check out the slides after the talk and look at them for the installation process. And then we will look at Jenkins pipelines. And finally, we will conclude this with some of the learnings that we had throughout our journey of getting started with build servers. So why does building your game manually suck? Because first of all, and this sounds pretty logical and kind of is always true, if we need a new build, we first have to make one. The bad part about this is building our project always takes time. We have to invest time to actually prepare the build. Maybe we have to fix compile errors and so on. Then we have to spend time waiting for the build. We can't do anything while we wait for the build, which is the worst part. Our machine is simply blocked for, I don't know, 20 minutes, 30 minutes as our project grows. Might even be hours that our machine is blocked. And then we still have to copy and install it to our target platform. And maybe we also have to do some in-between steps. And all this is a lot of work that is error prone. We are humans, we make mistakes all the time, and this is just normal and common. But if we make it in such a lengthy process, we will hate ourselves. And I really don't like to hate myself. Most of the time, when we need to make a new build, we actually need to make a new build for multiple platforms because we are developing games for Nintendo Switch, PlayStation 4, PC, Xbox One, whatever. There's a whole bunch of platforms, maybe even mobile, Android and iOS and so on. And this includes a lot of build processes. And for all of these, we have to do these steps again and again. Then making a manual build often involves a shift of work. We have to fix stuff that we fix specifically for this build. And then we encounter build compile errors, as I've just said. We have to go through the whole submission build processes and so on. And suddenly we go from developing our game, making changes, to getting it to our target platform. And because there's so much waiting time involved, we go back and forth between these. And this is one of the worst parts. As I just said, making a build blocks our work machine, and we can't do anything, at least in the time frame that the build is being compiled. And if we have automated tests in place, this is nice. But if we make manual builds, we have to also manually execute the automated tests. And running automated tests takes time. And in the end, this doesn't benefit us at all if we don't do it, because it takes time and we don't want to wait 20 minutes or more for tests to execute just to tell us that we didn't make any new breaking changes. And this really sucks. If we have a build pipeline, we can use the build pipeline to let it do this instead. And last but not least, tracking breaking changes is extremely hard. I don't know how frequently you are making builds, but I know that we made builds in intervals of months usually. And this means that there's no way for us to know when we introduce the breaking change. Best we can do is look at all the revisions between the last build and the new build. And those are usually hundreds or maybe even thousands of revisions that are between builds. And this makes it near impossible to figure out which exact commit was the breaking change. And then we have to go through a manual bug hunt where maybe the change that that was the breaking change, we don't even know about it anymore. We don't know why we made that change. And then fixing the bug is extremely hard. And last but not least, we have the famous "but it works on my machine" sentence. I guess we all know that. Somebody says, hey, the build compiles on my machine, it works. Why does it not compile on your machine? Maybe the reason is because they simply didn't check in new source code. Maybe there's more difficult processes involved, leftover build artifacts, some weird DLLs or whatever. Now, luckily, we have build servers that can help us to get rid of all this manual labor. A build server is an ecosystem that produces executables from our project in an automated way. We usually have one so-called leader, and the leader orchestrates one or more followers. The leader often also is referred to as the server, and the followers are often referred to as executor nodes that are available to the server. Some also call them agents. So the server receives a build request and distributes it to its followers. The follower then executes a set order of build steps, which in turn form the so-called build pipeline. If we look at this process in a graphical way, we do have our developer at the beginning. They make a commit to our version control system, and then we have our server that pulls the source control management system that we have. And because our server is a build server, it starts a build. At the end of this process, there is the build result, and this in turn then can be used to gather quick feedback and directly play the build, for example. We directly see if the changes that we made left the build uncompiling or tests are failing or whatever. And this all results in rather low turnaround times for a change, because I make the change, I commit the change, and just let's say 30 minutes later for the build process, I have the change directly in my new build. Build servers are a vital piece in every continuous integration pipeline, and they are often one of the most basic systems that people use when starting to embrace DevOps workflows. It can be used to automate many different tasks. Some of the more common ones are building our game, testing our game, and deploying it. If we want to take this simply, what a build server does is it takes care of producing and archiving builds of our game, and it does this in an automated manner. So how does our build server solve the issues I presented earlier? A build server simply solves them by, first of all, outsourcing the build process from our machine to another system. And the good part is we can finally keep doing what we love, and this is developing our game. Then we have our build servers that are dedicated machines for making builds. This means they are usually having repeatable and reliable build process. They don't do anything other than making builds. And just to be double sure, important build jobs can even clear the whole workspace as a first step. This in turn will make them take longer because we have to check out the repository again and so on, but then we are sure that our daily build doesn't have any weird outside influences. We can automate each step involved in our build pipeline. So this means that we can turn all manual labor into some sort of a build job and automate it instead. So no human ever has to do it again. This might include, for example, checkouting the project, importing it, building, testing, and so on and so on. The steps are basically endless, and we can do whatever we want in our build server. We can store one or multiple configurations per platform. So for example, I could set up a daily release build of my game for Windows 64, and I could do the same for Nintendo Switch. And then I won't have to build it for Switch, and I won't have to build it for Windows, which is nice because then all my build configurations are existing on a server, and they can be used to automate the process. It actually also helps us to bridge our QA team and our development team and basically every other team. Because if we have, for example, daily builds in place, then we have a nice way to offer everybody on the team an always up-to-date build. Each team member can simply go onto our server location and grab it and then download it and play it. For QA especially, this means they will have a centralized hub for where they can find new and centralized builds. And if they know how to use the build server, they can even produce a new manual build via using the server. And another nice thing that we can set up as a kind of end goal for our build server are continuous builds. These are the ones that we described earlier with the pipeline where a commit directly gets turned into a new build. And they, of course, help us finding breaking changes immediately. They help us to easily verify that our game at least still builds. And if we even have a test suite in place, our test suite on the server will make sure for us that the game also still functions. So here are some more key benefits. If we have notifications when something goes wrong, we are immediately notified. Our developers will know directly once the build failed. And luckily, there are often various integrations which suit exactly our workflow. For us, said it earlier, we are using Discord. So a Discord integration would be vital. For other companies, it might be communication via mail. For even others, it might be Slack or whatever. Who knows what's out there to use for communication. And this, of course, lets us know immediately when we broke our build. Over the time, we can automate even more and more processes using our build server. For example, we could start out with a simple pipeline that just takes our code changes and turns them into a build. And over the time, we could say, okay, now we'd like to also automatically deploy the process, the build onto our target platform. And if we do more DevOps things, for example, monitor some metrics, then we have a nice centralized endpoint for grabbing some metrics. And something that's less apparent maybe is that a build server, of course, can do work off hours. I can't make a build when I'm asleep because I'm sleeping. Then a build server can be configured to run while I'm sleeping and create a new build overnight. So let's look at a concrete number of time that we have saved at Threaks just by using a build server. And this number to me is pretty impressive. We keep in mind that we are using it for maybe 6 months. I think it's even a bit less. And we already saved more than 2,000 person hours. If you think about this for a second, then 2,000 person hours are equal to about 1 year worth of full-time work of a single person. This basically means we added another programmer to our team just by using Jenkins, and this involves almost no cash, except for electricity costs and so on. And the above calculation that I just showed you includes just the pure build time. It doesn't include all the work that is usually required to prepare the build, to upload it to our target platform and so on. If we would factor that in, the number would be exponentially higher. I'm pretty sure about that. So you might be asking now, what's the catch? And the only reason there is not to set up a build server really is this: maintaining this and setting it up, of course, takes time. But in the end, it will save you way more time than it costs you. So let's look at some of the options that we can choose from. Before we do that, we actually need to know, how do we make the right choice? In order to do so, we start with some stupidly simple methodology. We just write down what we need. And then we use those notes in order to compare them with all the available options. Here are some of the things that I found important and that we considered when we choose our build server system. First of all, I wanted to be running on a low budget because, yes, of course, I could invest huge amounts of money, but then I would somehow lose the point. And if I have a free and open source solution to my hands that works with my systems, then this would be great. Wouldn't be a killer argument to say, okay, we have to pay, I don't know, 20,000 or so for this. But of course, for smaller developers, maybe indie teams, paying 20,000 euros for a huge build server isn't really an option. So having a free and open source software for this is really nice. Then I wanted it to be open and easily extensible. This doesn't only include extensibility with code. Ideally, it would be extensible just by adding a few plugins or configuring it just so that it works in exactly the way that I want it to work, so I can tailor it to our workflows. Another thing I considered was the ease of use. Having good user interface and good user experience really is important when we talk about such a thing, because we are probably using it quite often, and the setup shouldn't be too complicated. And of course, there's more processes involved that should be rather easy. Last but not even last point, but one of the most important points actually is the compatibility. So for us, this meant that it should incorporate or should be compatible with Unity, with SVN, with C#, and all the technology that we use. For you, this might be different depending on your projects, but those were our requirements. Then a really important thing that we needed was being able to configure post-commit hooks or commit hooks in general. Those are the things that we can use to connect our repository with our build server so that we can have this nice automated pipeline where we go from change to direct build output. Actually, this is something that we won't look at in the comparison right now, because I found that most of the build servers available can do this anyways. So some of the available options that we looked at were Travis CI, TeamCity, a Unity specific one, which is Cloud Build, and Jenkins. There are way more options available, and if you start Googling for this, there's various systems for this. Those are just one of the popular ones. There are even more that are maybe even more popular, for example, Azure DevOps, but this is just a small selection. Travis CI has this nice logo and is a web-hosted GitHub continuous integration tool. It is free for use for open source projects. If you use or work on a commercial project, you can use it for free. And the build configurations are luckily quite easy to set up. You can simply use YAML files. Those are kind of similar to XML or JSON files or something like this. So they are easy to read and easy to configure. And the whole server itself is even easy to set up as well. The problem is it offers limited extensibility, so this wasn't too nice for us. And the pricing was a bit expensive for our needs. So you get 100 builds for free, and then it starts at $63 per year after that, depending on the number of concurrent builds that you are running at the same time. So the more builds you run at the same time, the more you have to pay for this, which means the more projects you have, the more configurations you have, the more likely you are to pay more money for this. Then there's TeamCity, again, another JetBrains product. As most of the JetBrains products, it's very easy to set up and it's very easy to use. It also comes, luckily, with a nice built-in integration for Unity, for example. And because of it being a JetBrains product, it does have fantastic out-of-the-box integration with all the other tools. So if you're using a lot of JetBrains tools, this might be a nice option for you. Again, this offers just limited extensibility, and the pricing, of course, it is not for free because it's a really great tool and it comes with nice, easy to use features. This means TeamCity is free for up to 100 build configurations and unlimited builds, but you only get up to 3 agents. If you want more agents, you have to pay $300 per agent per year. And after that, they also offer more expensive enterprise licensing models for bigger companies. Next on the list is Unity Cloud Build. Unity Cloud Build is a Unity service. This means you need Unity teams. And because it's a Unity service directly itself, it usually is easy to set up and to use with your Unity project immediately. Unfortunately, you have a quite heavy project size limit, which is 25 gigabytes. Everything above this requires custom plans for having a bigger project. And because it's a Unity service, you are required to have a Unity Pro or Unity Advanced subscription in order to buy into this. One of the worst parts for me is that Unity Cloud Build only supports a very limited array of platforms. For example, it does not support Nintendo Switch, and this was one of the killer arguments for us because we were making a Switch game. Then again, this has limited extensibility. On the other hand, there's not too much that you would want to extend at the beginning because it's working perfectly fine with Unity already. But if we are talking about more custom workflows and tailoring it to directly our company needs, then this comes in a bit unhandy. As I just said, it isn't free, so pricing means we can use it for free with up to 1 gigabyte or up to 25 gigabyte, depending on our Unity subscription model. After that, we have to pay an additional $5 per 25 gigabyte per month, or an additional $7 per seat per month, plus another additional $10 per concurrent build per month. Those are all rather small numbers, but they add up really quickly. Last option is Jenkins. And Jenkins, unfortunately, has the most complicated setup process of the 4, but in turn, it's heavily customizable just by using its built-in plugins. And this is really nice. If we want to, we can even write our own Jenkins plugins. We are required to use Java then because Jenkins was built in and with Java and originally was even built for Java applications only. Over the time, it was used for way more than just Java applications, but still this requires us to write Java code. Luckily, this is rather easy for us as C# developers to do because C# and Java are quite alike. A really big plus point is that Java is free and free open source software, so there's no cash involved, except for the electricity cost that I told you about earlier. Another good part is that Jenkins has a long and extensive background, and this means it already has a large community. There's long and battle-tested software, and it's just one of the most stable ones that you can find out there. So again, these are our 4 options lined up, and we at Threaks ended up with using Jenkins. We decided to do this because it was the cheapest variation, cheapest option available, and we said, well, if this isn't for us, then at least we didn't spend huge amounts of money, and turns out it was exactly the right thing that we needed. So this part we are actually going to skip. Luckily, the installation is quite easy, and as I said, you will receive the slides. The only part worth mentioning here is that if you install it, go for the most simple option to install it. This probably will be, I don't know, the Windows installation or whatever operating system you're using, because the instructions for this look like that. They are rather short and easy. And something that is very apparent in DevOps is using Docker. Docker is a tool that allows you to containerize your infrastructure and to, so to speak, deploy software in an isolated container, which is its own machine. So you can kind of emulate a new PC that runs only this Jenkins installation. Unfortunately, these are the instructions to install Jenkins in a Docker container. And if you're not familiar with Docker yet, then this is quite intimidating and complex. So you can skip this and optimize it by using Docker later on. So let's directly have a look at some pipelines. A pipeline usually consists of one or more build steps. This means that we can have varying build steps, and they usually depend on our use case. Some of the most common ones that we see throughout each pipeline is the following 3: a build step, a testing step, and a deployment step. And if we look at this in a graphical way, we see a similar representation as what we've seen earlier. We have our developer, they make a commit. The source control system the build server polls the source control system and fetches this commit, and then our build server starts doing their work. We have our friendly Jenkins fella here who starts making a build. After the build has finished, we do some testing, and then at the end we have our build result. This build result then is being deployed directly to our target machines, for example, PlayStation 4, Nintendo Switch, our local Windows machine, or maybe it's even deployed directly into the Sony PlayStation Store, because we are actually practicing continuous delivery already with our build pipeline. Now, I just said we can have a pipeline in our build server, but we can actually even have multiple pipelines, and we can make them specific for different use cases that we have. Some of the more common ones are, for example, a daily one. Those are the pipelines that produce builds, for example, nightly, so that there's always an up-to-date playable build. This usually means that if nobody is working anymore at that time, all the changes that we made in the team throughout the whole day are being incorporated with the build that's being produced in this daily build pipeline. And the next morning, then we have a playable build with all the changes from yesterday. Another common one is the manual build pipeline, which, unlike its name, still is being automated. But the manual part is that you actually still have to click the button in order to start that pipeline. This can be used, for example, to create a new build throughout the day. For example, let's say we made a few changes and we want to test them, and we want the full build process with all the testing and so on. This is incorporated in our manual build pipeline. We click the button, and after an hour or so of all the building and testing, we have our fully functional releasable manual build. Then we have release pipelines. Often the difference between a release pipeline and the manual pipeline is that the manual pipeline builds our game in the debug configuration, while our release pipeline builds it in the release configuration. So instead of receiving development debugging builds, we receive exactly the kind of build that we would also release to PlayStation, to Nintendo, and so on. The last one on the list is the continuous pipeline. Those are the ones that get triggered upon having someone in your team make a commit. And those are the pipelines that are used to verify that nothing broke while we made a change. As an example, we're going to look at making daily Windows 64 builds of our game. And we are actually looking at a quite simple example for this. So just the bare minimum that we need in order to get ourselves started with having daily builds for our game. The goal of this whole pipeline is to have a ready-to-use pipeline that creates builds of our game on a daily basis. We ourselves are usually hardworking indie devs, and the build should be done off work hours overnight, so that all our changes that we made throughout the day are being incorporated and that we see the fruits of our labor directly 24 hours later. The configured build should always be development builds, because we are very skillful developers, of course, but we know that we are also not the most trustworthy developers, and that we, from time to time, unfortunately introduce bugs, and we need to debug those bugs in order to have a nice playable game. Once the build has finished, we want a nice Discord notification, because Discord is our primary tool of communication, and we want to know that this build has actually happened. So what do we need for this? First of all, we need a Unity build script, because we are Unity developers. Secondly, we need a usable Jenkins installation. We don't need a lot, we just need one leader and one follower. Additionally to that, we need a few Jenkins plugins. Those are SVN, because for us at Threaks, we work with SVN. You might be working with Git, then you need the Git plugin, of course. we need the Unity 3D plugin, and we need the Discord notifier plugin. These can be installed rather easily. There's a slide earlier in the presentation, which we skipped now because of time reasons. But you can have a look there how you can install them. It's actually just a few clicks. So let's get started with Unity build scripts. All we need is a static method that handles our build process. We can then use the static method to call it via our command line by using the -execute method argument. This usually looks something like this. We have our execute method argument in the command line, so we can start Unity via command line and add this argument. And then it incorporates the method name, including the whole namespace. The code for this looks like that. We have our Jenkins build game method, and it's contained in our myBuildScript class in myProject.myBuildPipeline. What does our Unity script actually need to do? We want to set the destination folder, we want to name our build, and we want to configure it to be run as a development build with script debugging enabled. This can be done quite easily because it only takes us like 5 lines of code to write additionally. We include all the scenes that we want in our build. For example, our main scene, because we're making a nice procedurally generated roguelike. We require the location path of our game where we want to save it. And then we need the build platform that we want to build for. In this case, I said, let's build for Windows 64. And we require some build options. Those are the ones that we also configure when we manually press the build game button in Unity. In this case, we want development and allow debugging. After this, after having configured all this, we can simply pass in all the configuration as parameters into the build player function of Unity editor.buildPipeline. This, by the way, as I just said, calls the exact same mechanism as the build game button does in Unity. So now we are already finished with the Unity part, and we can jump into Jenkins. Jenkins looks something like this. I took this image from Wikipedia, so it's not our own Jenkins pipeline, but rather a very simple and newly set up one. So yours will look roughly like this in the beginning too. And before we do the actual work of the build jobs, we have to configure our plugins. The only plugin that needs configuration is our Unity 3D plugin. Unity 3D plugin does some nice work for us because it reroutes the editor lock and stuff like this and enables us to easily trigger a Unity build via Jenkins. Otherwise, we would have to do it with our own shell script or whatever to trigger it via command line. By using the Unity 3D plugin, we simply add a Unity build step, which is really nice. And so that this plugin knows where to find the Unity installation, we have to set it up. We do this in Jenkins by going to the global tool configuration and then simply scrolling down until we see Unity 3D. In there, we have to add our Unity installation. And once we've added our Unity installation, we have everything in place that we need. And this looks something like this. So if we are in our global tool configuration, there will be a section called Unity 3D. And in there, we can enter the name that we want to give it. This is not the name of Unity. This is basically a descriptive name that we can use to distinct between this Unity installation and another one, because maybe one of our projects builds on Unity 2020 and another project builds on Unity 2019. Then we have to configure the installation directory, and that's basically everything we need to do. By clicking this Add Unity 3D button here, we can add another installation by just entering new information for it. Now we get to actually set up the pipeline. The pipeline we will use consists of a freestyle job as a basis. A freestyle job in Jenkins basically is a job that doesn't give you any instructions beforehand. You have to do everything on your own. That's why it's called freestyle. In order to do so, we first find the navigation bar that you already saw in the bigger Jenkins screenshot, and then we simply click on New Item. This leads us to a new screen, and here we can give our pipeline a nice descriptive name, make it a freestyle job by selecting that, and then clicking OK. Once we've done that, we find ourselves with a new page that looks something like this. We are suddenly seeing a lot of options. This is one of the parts where that I described earlier. Setting this up is a bit painful, and getting to know all these options is a bit difficult. Luckily, you will see this when we go through all these different categories step by step soon. We do have these nice question marks there, and these nice question marks actually present us the documentation of what this functionality really does. So if we click it, we directly open the inline documentation for it. Let's have a look at the general panel. This is the first one that we encounter. It does offer some general settings. We can give our job a description. We can configure whether or not it's being run concurrently. Running a job concurrently means that we can execute 2 or more at the same time. If we don't allow it to run concurrently, we can only have one job running at the same time. The others will be queued and be executed afterwards. For our daily job pipeline, we have a nice simple job here because we can leave it as is. Everything is configured the way that we need it. Best we can do is maybe give it a nice small description, but we don't have to. For the other options, we won't bother too much now because they are not required to get us started. And they are actually really nice, and they all have their own unique use cases, but you will discover them as you go and as you work with Jenkins. Next up is the source code management panel. In here, we have to configure our settings for our version control system. And all we have to do basically is checking the version control that we use and configure it with everything that we need. For SVN, this looks something like this. We have our repository URL that we have to configure. We need to give Jenkins some credentials because Jenkins somehow has to check out all the changes in the project. And then we can configure more SVN stuff like externals and whether or not it should fail if externals fail, and so on and so on. The first really interesting part is the build triggers panel, because this is the one that allows us to configure Jenkins to run periodically and to make our builds on a daily basis. So this actually contains the information how our build gets triggered. In our case, we will simply use build periodically as an option. And this enables us to configure a so-called cron job that runs on our server. For those who don't know, a cron job is something that is used to run things on a schedule. There are rules on how to configure them. In our case, we want the cron job to be run each night, starting at 2 a.m. from Mondays to Fridays. We can put all this information in a nice short way into a cron job. And if this sounds unfamiliar to you, you should definitely check out this tool. I linked it in the presentation. It's called crontab Guru. And in there, you can simply play around with the numbers and letters of the cron job to see what it actually results in. In our case, we want this really simple cron job, which goes like H2 ** 1 to 5. So I guess most of you won't really know what this means, but below of the text box, there's actually a text indicating that this would have run last on Friday, July 17th at 2 a.m. and will next run on Monday at the same time. So this is exactly what we need. And we can use the tool that I linked here in order to check out which specific cron job we need for our needs. Next up is the build environment panel. The build environment panel includes some additional information for our build environment. For example, if we wanted to have timestamps in the log, or if we are using a specific keychain setup for our Apple development or whatever, and even a lot of more information. What we can do in here is ensure that we have a clean checkout by deleting the whole workspace before we start the job. And this is done easily by checking the delete workspace before build starts option. We can leave out all the fields empty because there's nothing that we need to include. We don't want to clear a specific directory. We don't want to clear a specific file. We want to clear the whole workspace. This will result in a complete recheckout of our project. And this then means our project is being built in exactly the same way it is in our repository. The BuildSteps panel is the second most interesting one, I would say, because in here we can configure our actual job and what it does. We can simply add a few build steps by using the Jenkins dropdown. Some of these build steps could be starting a shell script, triggering our Unity build, which we can do thanks to our Unity 3D plugin, or we could upload our build game to a server, for example. For our pipeline, what we want to do is we want to trigger the Unity build, and then we want to copy it to our server. For the copying part, let's just assume for now that we have a shell script in place that knows how to copy a file from A to B by using an SSH connection. If you don't know how to do this, then we can definitely talk about this later, or you can hit me up and I can send you some instructions on how to do so. So what we need to do is add the two build steps and then give some command line arguments onto our Unity build step that we actually need. This will be our build game method that we set up earlier. Once we're done, this looks something like this, and we could even add a few more build steps down here now. But the first step, as I said, is a Unity build step where we simply choose our Unity installation because we are on Unity 2019.3.13 right now. We are using that one. And then what we do is invoking it with a few command line arguments. Quit basically tells Unity to quit again once this job has finished, which is extremely important because if it keeps open, then we won't be able to use that job again because we can't open the same project instance more than once. And this is why we have to close it again afterwards. The batch mode argument ensures that Unity runs in headless mode and doesn't open the editor, but runs in the background rather. And last but not least is our execute method, which contains the build logic. And afterwards, we just execute a magic shell script that copies our script from our build machine to our server, where we can then download it and play it. The last thing that we have to set up is a post-build step. In our case, we want to perform a really simple post-build action because we have a plugin ready for this, our Discord plugin. And what we want to do now actually is to notify all our developers. We can, with a similar UI to the BuildStep UI, add such a new post-build action. And in here, because we are using Discord, we have to configure a webhook. You can find it on your server in the server settings. There you can simply create a new one and then copy and paste the link of the webhook here. And then you can give it a nice title so that you know what actually has happened. Configure all your needs, whether or not you want to include the build log, for example. And then this automatically gets sent to your developers once it's finished. And this is actually everything that we need to do. So there were a lot of steps involved, but configuring each step actually is quite simple and just requires a few checkboxes. And I think if you are having a finished Jenkins installation, you should find it rather easy to follow along these slides again and check the right boxes to have a nice daily build pipeline afterwards. This pipeline was rather simple. We have a bit more complex one. So what I'd like to do now is to tell you a bit about our pipeline. The first and most obvious addition that we have to that pipeline is having actually continuous daily release and manual builds in place for all our projects. So everything that we work on is being built about our build server. And for all these projects, we have all these build configurations available for all platforms that we ship to. For example, if we take Battle Planet Judgment Day, the game released on PlayStation 4, Nintendo Switch, and PC. Now, if we talk about the release builds this results in, we will have a Battle Planet release build for Windows 64, for Nintendo Switch, and for PlayStation 4. This means if we multiply this by all the configurations above, continuous, daily, release, and manual, we have a rather high number of pipelines that we require to actually make a build for just one project. This means all of them need to be maintained separately. And yeah, if you count that all together, we have 12 jobs suddenly for one game. That's quite a lot, if you ask me, and it's especially quite a lot if we manually need to maintain them. So you just saw in each pipeline that we configure, we have to configure the repository, we have to configure the steps, and then I have 12 jobs where I need to set up all the steps. If something about the step changes, I have to do it in 12 jobs. This multiplies even further the more platforms, the more configurations we have. What we did to address this is we actually split our pipeline into main and into build jobs. So those are just arbitrary names that I gave them. There's no scientific naming behind them, but build steps for us are the steps the jobs that actually take care of a specific step in our build process. So earlier we spoke about some of the typical steps that we can find in build pipelines: building, testing, and deploying. And what we did is we made one dedicated Jenkins job for each of these steps for our project. In the end, this looks roughly like this. We have our project, and for each build step that we have a new job. So we would have, for example, project name build step checkout, build step deploy, build step test, build step unity. This is nice because all these jobs contain the logic that our build steps do. Now, if I want to change logic about the build step, I have to change it in one place, as instead having to change it in 12 places, for example. Another key part is that these jobs actually are all configured to run concurrently. So I can have 2 Unity jobs running at the same time. This allows us to reuse each and every step for different main jobs. And as I just said, they are a central point, at least per project, where I can maintain each and every step available to us. The main jobs are actually the ones doing the real job, so to speak. They define things like configuration, build type, etc. And we actually do still have the same 12 jobs from before: release on Windows 64, on Switch, on PlayStation 4, on the same builds for our manual process, and so on. So they still look like this. But, and this is the nice part, they don't actually contain any build logic. What they do is they simply utilize our build step jobs, and they then piece them together by using a Jenkins build step, which is called trigger builds on other projects. So this allows us in our main jobs to, instead of execute all the build steps that we are doing, rather execute a build step that triggers another job, and then we can use the job that has all the checkout logic configured, for example. This means all the required information that we have is then passed down from the main job to the build step jobs by using parameters. This can be achieved by the parameterized triggers plugin. And now we have a rather modular set of build step jobs that can be used by the main builds, which now can piece together their desired pipeline. To understand this a bit better, let's look at a few examples. Those would be build steps that we have available for BattlePlanet. We have a checkout, a test, a Unity, and a deployment step. And what we can do now for a Windows release pipeline is simply put them together. First should be checkout, then I want my Unity build step. Next, I want to do some testing on the produced build, and in the end, there's the deployment. This is what our release pipeline does. Now, if I have a continuous pipeline, I usually don't want to deploy the game to my target platform directly or to the PlayStation Store or whatever. So what I can do is I simply leave that step out, and I still utilize the same other 3 build steps. Same, for example, if I have a different platform where I don't think I need to run tests, because on my main target platform, all tests actually already compiled and succeeded. So I will just assume that because they are the same tests, they still succeed on switch. And this way, we can build different pipelines really quickly by just piecing together our different jobs. To conclude this talk, I will give you some of the learnings that we had on our way of building up our build server infrastructure. The first and most important one is it actually saves a ton of time. And which is what is extremely relevant is that it enables us to do builds on a really extreme high frequency. I told you earlier that we saved 2,000 or more person hours. We didn't actually save 2,000 hours. But what Jenkins did was it enabled us to spend 2,000 hours in building the game. If I was about to go to my colleagues and say, hey, what about we add another programmer to the team and their sole purpose is producing new builds all the time we commit a change, we probably wouldn't hire this person. But we can hire a machine to do exactly that. One of the things that we learned painfully is that you should really stick to the same operating system across all machines. Mixing and matching them, so for example, Windows and Unix, or Windows and Mac, or Linux, or whatever, you will run into extreme problems doing so. And you can avoid these if you simply stick to the same operating system throughout all your build machines. And sometimes you might be required to mix them because maybe you're developing an Apple game and Apple actually requires you to work on a Mac, for example. Then you have to mix them. But if you can avoid it, do so. It will save you a ton of work. A build server actually requires a lot of discipline. Incorporating this fix over feature mentality and really stepping aside from working on a feature to fixing the broken pipeline requires a lot of discipline simply, and you just have to do it. There's no way around it. If you don't do it, you will end up with a build server that you set up and configured, and you won't have any benefits from it because it's broken. Customizability through plugins is extremely awesome, but it can also be extremely painful sometimes. An issue that we encountered, not quite sure if this is a common issue or has something to do with our specific pipeline, is that the Unity 3D pipeline actually was a pain. The Unity 3D plugin actually was a pain to upgrade. So when we changed the Unity version, we simply went into the plugin configuration again. And in the plugin configuration, we exchanged the installation directory string. After a while of having broken builds after Unity upgrades, we somehow figured that just exchanging the string doesn't work. It still looks for the old Unity installation. You have to add a new Unity installation in the plugin and set it up all new by using a new string because, I don't know, some weird caching issues or something. Running parallel builds on the same node works, but sometimes it has its quirks. So usually you can't open the same Unity project on one machine at the same time in the same directory. If we have multiple workspaces, then we can do it. This is how we solved it. But sometimes the manual build and the continuous build that we're running at the same time somehow mixed up their workspaces. So the manual build worked on the continuous workspace and the continuous build worked on the manual workspace, which obviously is not quite what we want. You can actually parameterize jobs. This is something that we learned about quite late. It's extremely nice because you can pass in things like revision number, which you can in turn use to name your builds. You can pass down the workspace and so on. And this is just extremely useful. This results in a different learning, being take your time to learn a new system or it will blow up. What we had was we changed our whole pipeline because we realized, okay, it's not quite working the way that we want. And after I changed the whole thing, I realized, oh, I can pass down the workspace too as a parameter, and this actually makes things a whole lot easier. And suddenly I had to redo the pipeline all over again, which in the end was extremely nice, but I could have taken 1 or 2 more hours to research this more thoroughly and realized it right from the get-go. Downstream jobs in Jenkins are extremely useful. They are the mechanism that allows us to piece together the different build step jobs. And if you're working with own command line arguments, for example, we are passing in our current revision number into the build process in order to name the build, is extremely painful unless you use a plugin for C#, which is called command line parser. This makes it really easy then. Using command line parser, you can have an options class that contains a revision number member, and then you can do something like options.revision number to retrieve that revision number. If you don't do it, you have to kind of magically remember which argument is your string and access it by using index 13 or something, which is extremely weird. The most important thing, again, is you don't need to be an expert on any of this to get started with it. None of us were experts on using build servers when we decided to do it. And I would argue none of us are experts yet. And it will probably take a lot of time until we become expert on this matter. But it already greatly benefited our development process. And that's it to conclude the last talk. Thanks everybody for listening. Let's see if you have any questions.
Thank you so much, Kevin. It was really nice. Great introduction. And as he already mentioned, we will share the slides later. Are there any questions? Yeah, we got a first question in chat. Yeah. Michael, how long did it take you to set up the server and tailor the build process?
So the first setup, the initial setup was done rather quickly. Let's say about a day or 2 maybe, until we figured everything out. And this included researching how to do it, establishing the SSH connections that we required, wiring all up in our local network, and having the first build produced by the build pipeline. And after that, it basically took weeks and months in order to develop the whole thing further and to see what fits our workflows, figure out what do we need, what don't we need, stuff like that.
Okay, great. Thanks, he says. Awesome. Are there any more questions concerning build servers or general workflows? I don't know, something.
Yes, I have another one. Earlier in the beginning of the presentation, you were introducing other potential services, and the one by JetBrains, I forget the name, was you said it can only have 3 agents. I don't know what an agent is. What is an agent in this context?
Good that you asked, because I should have explained that more thoroughly. The agent is the machine that actually makes the build. So in our case, or what I explained right in the beginning, not sure if you were joining then already, was the concept of a follower and a leader. The leader is the server, so to speak, and the follower is the machine that actually produces the build. And agent is just another term of referring to this follower.
Ah, okay, thanks. And so basically you can, with JetBrains, you can get 3 machines which build stuff for you for free.
Exactly.
Okay, so that's pretty cool already, right? To try it out, it would be probably pretty good. Okay,
yeah.
Thanks.
It's actually a nice starting point for a lot of developers, and something that especially a lot of Unity developers use because of the nice Unity integration. I would say if you're starting with TeamCity, then you are on the right track, and it makes a lot of things easier. Jenkins makes a lot of things a bit harder, but is more customizable. And thanks, and a big shout out to you, Linus, actually, for having me and for organizing all this.
Yeah, no problem. It was a pleasure to have you here.
Yeah, it was really cool.
Really great. Yeah, it was the closing act of the semester, as you said in your tweet. It really was. That's basically it for this term. Next talk will be in November, or probably November. Also, Christopher Wolf will be joining us next year, as he wasn't able to do it this year or this term. And besides that, we will be having some more diverse talks next year. So maybe an art talk, maybe some audio talks, and just to look into some other disciplines. If you have any suggestions or would like to hear a specific topic, feel free to hit me up. Otherwise, that's it for today. Thank you so much, Kevin. I will hit you up with more information about the video recording and stuff.
Awesome.
Thanks for being here.
Thanks for having me.
Have a great day, everyone. I will quit this session now.
Thank you, Linus. Bye.
Bye.
Thanks,
Bye.
Kevin. Awesome talk.
Thanks you all for listening.